All right, greetings, YouTube. Beautiful mind here. Um, hope everyone is doing well. Hope everyone had a great weekend. This will serve as week 5 lecture for week 5 Monday. Let's see. Any announcements? We had exam 2 due over the weekend. Uh, I will be getting we'll be getting the access codes that we have extended. So if I think I had a few students here that don't have full access. So if you don't have full access, in the next few hours, try the access code again, and it should grant you full access. It's that these codes only work probably through the end of the week. So you want to go ahead and get that submitted. So exam 2 was due this past Saturday. It is still available with the late penalty. And then this week we're going to be moving into, I think it's chapter 5. So, just be on the lookout for assignments associated with these lectures along with a quiz. So I'll probably try to get these materials up as soon as possible. Keep in mind that I am monitoring the live chat. Whenever I go live, I typically monitor the live chat. So if anybody were to come on and ask questions in the live chat on YouTube, that's fine. I try to do my best to respond to emails. Also, be sure that you're making use of the Ask My Instructor. Okay. There's a so each question comes with an explanation. If the explanations provided by Pearson don't work, you can make use of the Ask My Instructor. It'll send me a copy of the question that you're working on, and I can do my rendition of it. Also, we have tutors available, so you can schedule an appointment with them, and you can go live with them as well. Okay, I can't really think of any other major announcements, so I'm going to move into the material for today. Let me go like this. Okay, I think this will work. All right. So we're going to be moving into chapter 5, normal probability distributions. So section 5.1, we're going to look at an introduction to normal distributions and the standard normal distribution. Okay. So some objectives here are how to interpret graphs of normal probability distributions and how to find the area under a standard normal curve. So some properties of a normal distribution. We have continuous random variable. It has an infinite number of possible. So I think last time we looked at examples that were a discrete random variable where it was a countable number of outcomes. So for a continuous random variable, it has an uncountable number of outcomes. They're both infinite, or they can both be infinite. But in this context, there's so many that we can't even begin to count it. So this has an infinite number of possible values that can be represented by an interval on a number line. A continuous probability distribution is going to be the probability distribution of a continuous random variable. So for instance, in this example, we have the hours spent studying in a day. What's the least number of hours that someone could spend studying is 0. What's the most number of hours that someone could spend studying in a day is 24 hours. Is it possible for someone to spend 1 hour studying? Yeah. Is it possible for someone to spend half an hour? Yeah. What about a quarter of an hour, eighth of an hour? All of these are yes. So with that kind of context, that's an example of what we mean by a continuous random variable. So then the normal distribution, a continuous probability distribution, this is going to be a continuous probability distribution for a random variable x. The most important, the normal distribution is the most important continuous probability distribution in statistics. The graph of a normal distribution is called the normal curve. So it has this bell-shaped figure, all right? So that's there's a lot of applications using this kind of distribution. So some properties of the normal distribution: the mean, median, and mode are equal. So these are all the mean, median, and mode. The normal curve is bell-shaped and is symmetric about the average. The total area under the normal curve is equal to 1, and the normal curve approaches but never touches the x-axis. Let me see. I could fit the display. I'm trying to think of a good way to get it done now. Give me a moment. I'm gonna try something. All right, so we're back. So I'm gonna use a different, something a little different. I mean, so I'm kind of torn between two applications, but I mean we'll use this one for now. It'll be fine. Okay, so we went through all of that. Let's get to where we left off. Okay, so oh shoot, does it have a? Let's see, can I? No. All right, well we'll just work with that. Okay, so the mean, median, and mode are equal. The normal curve is bell-shaped and is symmetric about the average. The total area under the normal curve is equal to 1, and the normal curve approaches but never touches the x-axis as it extends further and further away from the average. Okay. So between mu minus sigma and mu plus sigma, or mu minus one standard deviation and mu plus a standard deviation in the center of the curve, the graph curves downward. Then the graph curves upward on the left of this point and on the right of this point. The points in which the curve changes from curving upward to curving downward are called inflection points. Okay. A discrete probability distribution can be graphed with a histogram, so it's a bar graph. For a continuous probability distribution, we can use a probability density function. A probability density function has two requirements. The total area under the curve is equal to 1. The function can never be negative. Okay. A normal distribution can have any average and any positive standard deviation. The average gives the location of the line of symmetry. The standard deviation describes the spread of the data. Okay, I'll let you go through that on your own. Let's see what we got. So which curve has the greatest average? So for curve A, the average is what, like 15, and for curve B, the average is 12. So that means curve A has the greater average. Which curve has the greater standard deviation? So which curve is more spread out? Curve B is more spread out than curve A. So we have this example on interpreting graphs of normal distributions. It says the scale test scores for New York State Grade 4 Common Core Mathematics test are normally distributed. The normal curve shown below represents the distribution. What is the average test score? Estimate the standard deviation of this normal distribution. So it says, what is the average? What is the mean? So if we look right about here, let me see, what is that? If that's 280, 300, 310, 320, no. 85, 90, 300, 305. What is that? If that's 280, how many tick marks? 1, 2, 3, 4, 5. So 10, right? 90, 100, 20, 30. What? 1, 2, 3, 4, 5. So 30 and 20 is 50. Should be 10. 90, 300, 310, 320, 330. Okay, there we go. So if this is, let me see, 90, 300, it looks like it's about 305. What is the average test score? I would say it's approximately 305. Estimate the standard deviation. So the inflection point, it goes from curve up to curve down about here. So that's 330, 40, 50. So the standard deviation is approximately 45, because it goes from 305 to 350 approximately. And we're saying our mu is approximately 305. Let's see, how do we do? 305 and 40. Is that what we said? 40? We said 45. That's okay. Okay. All right. Oh, I think we missed a question. No, we're fine. So using the empirical rule, we know that about 68% of the scores are between 265 and 345, 95% are in that range, and 99.7 are in that range. So a standard normal distribution, a normal distribution with an average of 0 and a standard deviation of 1. So what we're doing is we're taking these standard normal curves, we're taking these normal curves and standardizing them. So we're resetting the average, essentially setting that to 0, and then whenever we have a negative standard deviation, that moves it to the left of the average, and whenever we have a positive standard deviation, it moves it to the right of the average. So the area under the curve is 1, and now 0 is now our average. Any x value can be transformed into a z-score by using this formula. The x value minus the average divided by the standard deviation, and that'll give us our z-score for the standard normal distribution. Okay. I'm gonna let this be. All right, let's try this one. Find the cumulative area that corresponds to a z-score of 1.5. I think we would need a chart. So there's a chart in the back of the text. It looks kind of like this. So once we have the z-score, so what's kind of going on, you see over here on the left, we have the standard normal curve. So a z-score of 1.5 is positioned here. So what the chart is telling us is telling us the area under the curve to the left of this 1.5, right? So if we go to the chart, we have the z-score of 1.1, and then we see the 0, 1, 2, 3, 4, 5, and they cross here. So the area under the curve to the left of 1.5 is about 87.49%. Okay. So the area under the curve to the left of a z-score of 1.15 is 0.8749. Found the cumulative area corresponding to a z-score of a negative 0.24. So again, the chart. There's a second one that gives us a negative z-scores. So we go to the negative 0.2, and then we go over to the 5. 987,654. Sorry, we go to the 4. So then about 40.52% of the curve is to the left of this z-score. Okay, I'd rather just work an example. All right, so I'll let you kind of go through that on your own. Okay, I just want to work some examples. Okay, we're asked to find the area under the standard normal curve to the left of 0.99. Okay, let me see if I can pull up this chart. So if we're here, cool, that's not showing, which is not supposed to do. Cool. Let me pull up the chart. It's this one. And if I go to the table, I think it's here. Standard normal curve tables. Standard normal distribution table 4. Okay. So let's switch this over like this so you guys can see it. I think there is a way to get rid of that, but I don't know how to do it right now. So, all right. So we're asked to find the area under the curve to the left of negative 0.99, right? So I'm going to shrink that down a little bit. So let's see. This chart, notice it says continued at the top. So that's not the one we want. We want this one. Because notice our z-scores are negative on the left. Okay. You can't really see my cursor. Let's see. So if we want to find the area under the curve to the left of negative 0.99, so you see at the bottom on the left, so on, let me see, 2, 4, 6, 8, the 10th from the bottom, we have negative 0.9. And then if we want negative 0.99, we go to the right, we get this negative 0.1611. Negative 0.1611. Let's see, how do we do? So we got negative 0.1611 by looking at the chart. You see it there, negative 0.1611. Find the area under the standard normal curve to the right of 1.06. Okay, let's go back to our chart. So we're asked to find the area under the curve to the right of 1.06. Now notice that z-score of 1.06 is positive, so I'm going to go to the next page. 1.06 is it's kind of near the middle. You see the 1.0, and then you got 0, 1, 2, 3, 4, 5, 6 is 8554. So the 8554 tells us the area of the curve to the left. So the 8554. So then what we need to do, we got to say, if we want to the area of the curve to the right, we got to say 1 minus the 85. We got to say 1 minus the 8554. Let's see. That's going to be a 644. I think it's this, right? 14.46. Let's see, how do we do? 14.46. Okay. So again, the chart gives us the area to the left. Whenever we want the area to the right, we got to say 1 minus that result. That's called the complement rule. Okay. Find the area under the standard normal curve between these two. So what we'd have to do is find the probability of each, find the area under the curve to the left of each, and then subtract the two results. Okay, so let's go back to our chart. So the first z-score was a negative 1.5. Negative 1.5 all the way to the far right is the 0668. And then the other one was 1.25. 1.2, 0, 1, 2, 3, 4, 5 is 8994. So then we want to subtract those two. Okay, let's see, how do we do? So if we subtract them, that becomes what, 8, 14, a 6, 2, wait a minute, and 2, 3, 8. 8326. Let's see, how do we do? 8326. Oh, close. I think I don't know. I didn't see. I probably should have kept what I wrote. Probably didn't read the chart properly. Let me see. 8994. I think those are correct. I think I just didn't subtract properly. Okay, but we got the idea. Just subtract the two. Okay. Oh, was that it? No. No, it's over. All right. Okay. Well, that was a lot of fun. Let me think about it. So we'll go ahead and stop there for the time being. Again, I am available just if you have questions and things of that nature. Let's just be sure to get our assignments submitted promptly. I'll go ahead and load some assignments, and I might even go ahead and load the quiz. We get a limited attempts at these assignments until the deadline, and then past the deadline, we still get a limited attempts at it, but there's be a late penalty. Okay. And on that note, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your day. Peace.